30,000 board feet of lumber in a single day. In 1855, that number changed everything west of the Mississippi River. Before steam-powered circular saws arrived on the American frontier, a water-powered mill running at full capacity might produce 1,500 board feet in the same period. That meant 20 times the output, overnight. This wasn't gradual improvement, it was annihilation of the old order. The conventional story says railroads opened the West, that iron horses and steel rails conquered the wilderness. The documented reality says something different. You couldn't build railroads without lumber, and you couldn't produce lumber at scale without steam. Enjoy our walk in the park video while listening to facts about Wild West. By 1860, the railroad industry alone consumed 1/4 of all American lumber production for ties, trestles, freight cars, and stations. The technology that actually built the frontier wasn't the six-shooter or the locomotive. It was the screaming steel disc spinning at 400 revolutions per minute, converting ancient forests into 2x4s at a pace medieval craftsmen couldn't have imagined in their wildest speculations. Picture Winona, Minnesota Territory, October 1855. The town sits on a limestone bluff overlooking the Mississippi River, population perhaps 3,000 souls. Most of them arrived within the last 2 years chasing opportunity in a territory that had only gained that legal status in 1849. Steamboats crowd the levee below, their twin smokestacks belching coal smoke into the crisp autumn air, their decks stacked with McCormick reapers and breaking ploughs headed west to prairie farms, their holds waiting empty for something valuable to carry back to eastern markets. The air smells of pine sap, coal smoke, and the earthy dampness of the big river rolling past at 4 miles per hour. A half-mile from the waterfront, past the muddy streets and raw lumber storefronts where everything from boots to bacon sells at frontier markups James Highland and James Wycoff are about to change the economics of an entire region. Their new mill stands beside a tributary creek, but the creek provides no power for the operation. The water is too shallow, the gradient too gentle to turn a wheel with any authority. Instead, a 15-horsepower steam engine, its boiler fired with scrap from its own operation, feeds a 48-inch circular saw blade mounted on a steel arbor, spinning at roughly 400 revolutions per minute. A secondary muley saw handles roughing cuts on oversized logs. The system feeds itself in a closed loop of industrial efficiency, burning the slabs and edgings that have no commercial value to generate the steam that powers the machinery that creates more slabs and edgings. When the blade first bites into a 16-foot white pine log that October morning, it doesn't stop until the log becomes boards. No return stroke wastes time. No pause at the top of the cycle interrupts production. Continuous cutting at a pace the human eye struggles to follow. Contemporary accounts describe what happens next with unconcealed amazement. The mill processes logs faster than men can stack the finished lumber. Cants accumulate waiting for the edger. Boards pile up awaiting the sorting crew. Within a month of commencing operations, Highland and Wycoff are producing 30,000 board feet daily, what local newspapers called, and the phrase merits close attention, a quantity heretofore unheard of in the frontier country. The mathematics of this transformation deserve careful consideration because they explain everything that happened to the American West over the following half-century. A skilled 2-man pit-sawing team working from dawn to dusk with a 7-foot whipsaw might convert one large log into usable boards in a full working day. Perhaps 50 board feet in 12 hours of back-breaking labour, the top man guiding the cut along a chalked line while the pitman below pulls the saw down through the timber in the sawpit trench, sawdust raining into his eyes and lungs with every stroke, his arms and shoulders screaming by mid-morning. The same log runs through Highland's steam-powered circular saw in under 5 minutes. The same 2 men who might have spent all day producing 50 board feet can now stack 10 times that amount per hour. This wasn't incremental improvement in established techniques. This was industrial transformation, operating at the speed of spinning steel, rewriting every assumption about what was possible and what was profitable. The men who made this revolution possible weren't cowboys or gunslingers. They weren't the frontier characters who populate dime novels and Hollywood westerns. They were mechanical engineers and metallurgists and millwrights, educated men who understood that building the American West required first solving a manufacturing problem that had constrained human civilization for millennia. How do you convert standing trees into usable construction? Material at a pace that matches the rate of westward settlement? The circular saw had existed in concept since at least Samuel Miller's 1777 British patent, but early versions couldn't handle large timber. The blades overheated under sustained use, the friction of continuous cutting raising the steel temperature until the metal softened and deformed. They developed wobble that produced wavy, unusable cuts worth less than the labour required to make them. They shattered under stress, sending razor-edge steel fragments through mill buildings at lethal velocities. The breakthrough came from learning to hammer saw blades into perfect tension, a skill that transformed raw steel discs into precision-cutting instruments capable of surviving hours of continuous operation. A saw filer, which became a specialised and highly paid trade on the frontier, worked the blade with hammer and anvil, introducing calculated distortions that counteracted the thermal expansion caused by friction heating. The centre of the blade had to be looser than the rim. The rim had to be tensioned differently on the teeth side than on the centre. The process was as much art as science, requiring years of apprenticeship to master. By the 1840s, American manufacturers had developed standardised techniques for tensioning large circular saws. The inserted tooth design, patented around 1840, allowed damaged cutting surfaces to be replaced without scrapping an entire expensive blade. This matters economically. Remember that a single large circular saw blade cost more than most frontier farmers earned in an entire year of labour. A 48-inch blade represented months of specialised manufacturing. The ability to repair rather than replace represented enormous capital savings that made remote frontier operations economically viable. Steam changed the geography of possibility in ways that reshaped the entire continent's development pattern. For 200 years, American sawmills had clustered, exclusively around rivers and streams because falling water provided the only practical power source for industrial machinery. A mill needed a dam and a flume, and sufficient hydraulic head to turn the wheel that drove the saw, with enough force to cut through hardwood without stalling. This geographical requirement meant lumber production concentrated in specific locations, regardless of where the trees actually grew or where the settlers desperately needed boards for construction. The vast forests of Wisconsin and Michigan sat largely inaccessible in the continental interior, sometimes just a few miles from settlements starving for lumber, but located too far from any stream with sufficient gradient to power a mill capable of commercial production. Steam engines operated anywhere you could deliver fuel and water. The portable steam sawmill could follow the logging camps into the wilderness, converting trees to dimensional lumber at the point of harvest rather than floating logs, hundreds of miles downstream to distant mill sites. A steam rig might arrive at a new timber stand one week and begin commercial production the following week. When the local trees were exhausted, typically within 2 to 5 years of intensive cutting, the machinery could be dismantled, loaded onto wagons or rail cars and transported to fresh timber. The mill came to the forest rather than requiring the forest to come to the mill. This seemingly simple reversal rewrote the economics of Western settlement. Understanding the scale of technological change requires baseline numbers from the old system. By 1840, New England possessed roughly 5,500 sawmills, supplying the established eastern states with construction lumber. Almost all were water-powered sash mills using technology essentially unchanged since the 1630s, when the first European-style mills began operations near Berwick in present-day Maine. The reciprocating sash saw operated through an elegantly simple mechanism that a village carpenter could maintain. A wooden frame, the sash, held a straight blade about 6 feet long and tension between upper and lower crossbars. A pitman arm connected the sash to a crank on the water wheel axle. As the wheel turned with the river current, the sash moved up and down in wooden guides greased with animal fat. The blade cut only on the downstroke. The log, mounted on a ratchet-driven carriage, advanced only during the upstroke when the blade was rising and not engaged with the wood. Maximum speed depended entirely on the mass of the saw frame. The heavy wooden sash couldn't withstand higher velocities without vibrating itself into destruction or tearing the blade from its mountings. 60 to 100 strokes per minute represented the practical ceiling that 2 centuries of refinement had established. A single board might require dozens of strokes to complete depending on wood hardness and blade sharpness, and each board required resetting the log on the carriage before the next cut could begin. Production maxed out around 1,500 board feet in a 10-hour workday, assuming no mechanical failures, adequate water flow through all seasons, and experienced operators who understood the machinery's temperament. The muley saw represented the first significant improvement in this ancient pattern. By eliminating the heavy wooden sash and driving the blade directly through metal guides, muley mills reduced reciprocating mass and increased speed to roughly 300 strokes per minute. Output doubled to approximately 3,000 board feet daily, enough to supply a small settlement's construction needs. But the muley saw still cut only on the downstroke. Half of every cycle produced nothing but the upward motion required for the next cut. Energy expenditure stayed constant, while productive output occurred only half the time. Steam-powered circular saws obliterated both benchmarks completely. The blade cut continuously, every rotation removing wood. There was no return stroke, no wasted motion, no dead time in the cycle. Highland and Wycoff's Winona mill wasn't exceptional in its output figures when measured against what followed. It was simply early, among the first frontier operations to demonstrate what the technology could accomplish at scale. Within 5 years of their October 1855 startup, steam circular mills across Minnesota, Wisconsin, Michigan, and the Pacific Northwest were matching or exceeding that 30,000 board feet daily production figure. Some larger operations, running multiple saws fed by steam-powered log conveyors and employing crews of 30 or 40 men, achieved 100,000 board feet in a single shift. The California gold rush had already demonstrated with painful clarity what happened when lumber demand catastrophically outstripped supply in a rapidly growing region. In San Francisco, 1849, lumber prices exploded from $50 per thousand board feet to $500 as the population surged from 2,000 hopeful souls to 60,000 frantic gold seekers within 6 years. Ships sailing from New England around Cape Horn carried lumber in their holds, along with mining equipment and trade goods, a journey of 15,000 nautical miles requiring 6 months or more to deliver boards that grew in forests just 300 miles north of San Francisco Bay. The economic absurdity was obvious to anyone who examined a map. The Pacific Northwest contained the largest stands of merchantable timber on the North American continent, forests of Douglas fir and western red cedar that dwarfed anything remaining in the east, but possessed essentially zero manufacturing capacity to convert standing trees into construction material for the booming California market. Henry Yesler solved this problem for Seattle and transformed a mud-flat settlement into a city in the process. His steam-powered mill began operations in late March 1853, the first steam sawmill on Puget Sound and the catalyst for Seattle's subsequent growth. Lumber sold for $35 per thousand board feet, a price that made Yesler's operation highly profitable, while simultaneously undercutting imported eastern lumber by more than 90% and capturing the entire regional market. The savings went directly into accelerated construction that attracted more settlers who needed more lumber. The mill employed virtually every adult male settler in King County at one point or another, either cutting logs in the surrounding forests or stacking boards at the mill site, or handling the schooners that carried finished lumber to San Francisco. When Yesler couldn't find sufficient white labor for his expanding operations, he hired Native American workers from the Duwamish and Suquamish peoples who had lived around Elliott Bay for generations, paying them fairly and gaining a reputation for honesty that kept his operations running when other frontier enterprises failed for lack of hands. The sawdust from Yesler's mill filled the tidal swamps surrounding the original settlement, creating buildable land from marsh. The scrap slabs built wharves extending into Elliott Bay to accommodate larger vessels. The dimensional lumber built the city that would eventually become a gateway to Pacific trade and Alaska gold. One mill, one man's entrepreneurial vision, one steam engine converted trees to lumber and lumber to urban infrastructure with industrial efficiency. Chicago emerged as the central distribution hub that connected western forests to eastern markets and prairie settlements, the point where raw materials flowed in and finished goods flowed out to build a continent. The Illinois and Michigan Canal, completed in April 1848, linked the southwestern shore of Lake Michigan to the Illinois River and through it to the entire Mississippi watershed. Lumber floated or steamed across the lake from Wisconsin, and Michigan mills could continue by canal boat and river steamer to St. Louis, Memphis, Natchez, New Orleans, and every settlement and farm along the way. The trade pattern reinforced itself geometrically with each passing season. Farmers bringing wheat wagons across the flat Illinois prairie to Chicago grain elevators returned home with loads of dimensional lumber for frame houses and outbuildings. More farms meant more demand for lumber. More sawmills meant cheaper lumber. Cheaper lumber meant more farms could be established, more towns platted, more railroads built. The cycle accelerated continuously. Railroad construction multiplied everything else. Each mile of track required approximately 2,500 wooden ties spaced roughly 2 feet apart on the graded roadbed. A single locomotive consumed 1 full cord of cut firewood every 30 miles, before coal became the standard fuel source in the 1870s. Railway depots and freight houses, passenger cars and baggage cars, bridges spanning rivers, and trestles crossing valleys all demanded lumber in quantities no previous generation had contemplated or could have supplied. Railroad companies became simultaneously the largest lumber purchasers in the country and the primary transportation network that moved finished lumber from mill towns to construction sites across the expanding nation. The relationship was perfectly circular and mutually reinforcing. Railroads needed lumber to build track, and lumber mills needed railroads to reach markets beyond river navigation. Neither industry could have grown as rapidly without the other. The production transformation happened faster than even the most optimistic projections predicted. In 1850, lumber ranked as America's largest manufacturing industry by value of output, ahead of textiles and iron and every other sector. Minnesota's first commercial sawmill at Marine-on-St. Croix had opened for business in August 1839, a water-powered flutter wheel operation that produced roughly 5,000 board feet in its first winter of cutting. By 1877, that same mill site, rebuilt and expanded and re-equipped multiple times over 4 decades of continuous operation, was turning out 2 million board feet of lumber annually, plus 500,000 shingles and 200,000 laths. The permanent workforce remained around 14 men. Machinery had multiplied human productive capacity by a factor that defied easy comprehension or historical comparison. The kerf became an industrial obsession, the subject of patents and trade secrets, and heated technical debates in lumber industry journals. Early circular saw blades measured fully half an inch thick, solid steel necessary to prevent the blade from wobbling or buckling under the continuous cutting stress that would have destroyed a thinner disc. Each pass through a log wasted a half-inch strip of valuable wood, converted to nothing but sawdust that accumulated in enormous piles beside every mill. On a typical log, yielding perhaps 20 boards, that represented 10 full inches of lost timber, very nearly an entire additional board simply vanished into the sawdust pile, with every log processed. Metallurgical advances gradually reduced blade thickness to a 1/4 inch by the late 1860s. Bandsaws, introduced commercially in the mid-1870s, cut waste further to just 1/8 inch of kerf by using a continuous loop of thin, flexible steel rather than a rigid spinning disc. The economics of kerf improvement mattered enormously when mills processed millions of board feet annually. A 1/8 inch reduction in blade thickness across a yearly production run of 10 million board feet translated to hundreds of thousands of dollars in additional saleable lumber from the identical raw material input. Mill owners invested heavily in any technology that promised kerf reduction, and saw manufacturers competed fiercely on thickness specifications measured in 64ths of an inch. Production figures from the peak logging years stagger modern comprehension. By the first decade of the 20th century, Minnesota alone produced 2.3 billion board feet of white pine lumber annually, harvested from forests that had seemed inexhaustible just 50 years earlier. 20,000 lumberjacks worked the northern pineries each winter, felling trees and skidding logs across frozen ground to riverbanks and railroad sidings. Another 20,000 men operated the state's sawmills during the spring and summer cutting season. The Minnesota Historical Society later calculated that the 1905 harvest alone contained sufficient lumber to build 600,000 standard 2-story houses, or alternatively to construct a continuous wooden boardwalk 9 feet wide around the entire circumference of the Earth at the equator. West Virginia, arriving later to large-scale industrial logging, but cutting with even greater intensity using the newest bandsaw technology, produced 30 billion board feet of timber between 1880 and 1920. The State Historical Society offered its own staggering visualization: enough lumber to construct a boardwalk 2 inches thick and 13 feet wide, stretching from the surface of the Earth to the surface of the Moon, a distance of roughly 239,000 miles. By 1909, the peak year of West Virginia production, 83 band mills and nearly 1,500 smaller circular operations were simultaneously stripping the Appalachian forests of trees that had been growing since before European contact with the continent. The human cost rarely appears in the production statistics that lumber companies preserved and historians later compiled. Sawmill work ranked consistently among the most dangerous industrial occupations in 19th century America. Circular saw blades spinning at 400 revolutions per minute had no guards, no safety switches, no automatic shutoffs. A moment's inattention, a slip on a wet floor slick with sawdust and water, log shifting unexpectedly on the carriage meant lost fingers, lost hands, lost arms, lost lives. Steam boilers exploded with devastating regularity, especially in remote frontier operations where maintenance standards varied wildly, and pressure gauges were often ignored in the push for maximum production before the timber ran out. Log handling killed men routinely through crushing injuries and drowning in mill ponds and log drives. The labour force that physically built the wooden infrastructure of the American West paid for that construction, in blood and suffering that the historical record seldom troubles to document with the same precision it reserves for board feet produced and profits earned. Highland and Wycoff's Winona mill ran for years after that transformative October morning in 1855. Processing logs floated down the Mississippi from the Wisconsin and Minnesota pineries in enormous spring log drives that clogged the river for miles. The specific fate of their particular operation eventually disappeared into the larger narrative of Minnesota's lumber boom and inevitable bust. What remained was the production model they helped establish. Steam power driving circular blades through western timber at speeds that transformed raw standing forest into dimensional lumber, fast enough to build cities, railroads, farms and factories across 1,000 miles of previously untamed territory. The conventional historical story credits the Colt revolver, the Winchester repeating rifle, and the Transcontinental Railroad with winning the American West. The documented evidence suggests a rather different conclusion. Armies marched on supplies carried in lumber-built wagons to lumber-built forts. Settlers lived in lumber frame houses heated by lumber-burning stoves. Miners worked in tunnels supported by lumber shoring and lumber cribs. Cattlemen fenced their range with lumber posts strung with lumber-manufactured wire. The West was won board by board, 2x4 by 2x4, and every single board came screaming off a saw blade in a steam-powered mill. By 1890, the eastern forests that had seemed limitless were exhausted. The great white pine stands of Michigan, Wisconsin, and Minnesota that pioneers had viewed as obstacles to agriculture in 1850 had become cut-over wastelands of stumps and logging slash that burned in catastrophic wildfires. The lumber barons who had grown wealthy, converting public forest to private profit, simply packed their equipment, gathered their capital, and moved their operations to the Pacific Northwest and the southern Pine Belt, beginning the extraction cycle again in fresh timber. Steam technology had made possible a rate of harvest that outpaced any conceivable natural regeneration. The circular saw, capable of converting a 500-year-old tree into saleable lumber in 5 minutes flat, enabled a consumption pace that emptied entire river watersheds within a single human generation. Renon-St-Croix tells the final chapter of this industrial story in miniature. The town that grew up around Minnesota's first commercial sawmill changed its very name when that mill finally closed its doors in 1895. Marine mills became Renon-St-Croix because there simply were no mills remaining to justify the older designation. The timber was gone. The machinery was sold off piecemeal to other operations further west where trees still stood. In 56 years of continuous operation, that single mill site had processed 197 million board feet of lumber, built a regional economy, sustained a working community through 2 generations, and ultimately rendered itself obsolete by consuming the forest resource that justified its existence. Water-powered sash saws cut at 80 strokes per minute and produced 1,500 board feet daily. Steam-powered circular saws spun continuously at 400 revolutions and produced 30,000. Those production numbers explained everything that happened to the American frontier between 1850 and 1900. They explained nothing about what came afterward. The technology hadn't changed when the last mills finally closed. The resource had simply vanished. And when the merchantable timber was entirely gone, the mills moved on to fresh forests, leaving behind company towns, that had no further economic reason to exist, and devastated landscapes that would require a full century to recover even a fraction of what 50 years of industrial logging had stripped away. The 30,000 board feet that rolled out of Highland and Wycoff's Winona operation that October morning in 1855 represented far more than technical achievement or production records. It represented a fundamentally new relationship between human industrial capacity and natural resources, a relationship characterized by unprecedented efficiency and equally unprecedented rates of consumption. The steam-powered circular saw didn't just build the American West, it established the extraction pattern of exploit and exhaust that would define American industrial expansion for the following century and beyond. The blade that could cut 30 times faster than any previous technology could also deplete a continent's forests 30 times faster than anyone in 1855 anticipated or imagined possible.